Soil Secrets. My name is Michael Martin Melendrez, and I own a soil health company in Los Lunas, New Mexico that's involved with producing molecular biology products that can improve the health of soil regardless of where you are on the planet. Today I'm going to talk to you about a product that we manufacture in Los Lunas called TerraPro, and give you a little bit of history as to how we got from where we were 30 years ago to where we are today. So three decades ago, I began looking at who are the microbes living in soil and what exactly do they do for us. I was curious about this because I own a tree farm and where I focus on growing the native trees of the Chihuahuan Desert region, and I discovered that if I could implement the use of these native microbes that are part of the root system of these trees, that the trees would actually do better for us in a production nursery environment. So I had to go out and dig up the soil, dig up roots, and with the help of several different scientific institutions, identify exactly who are these microbes and what benefit are they providing us. And so that was the beginning of this whole process of what became eventually the company Soil Secrets. In 1998, I began research looking for what we call the humic acid or humic acids, a theoretical substance of soil. And the image I'm showing on the screen is actually the theoretical molecular structure that Stevenson published back in 1982. So we began looking for this, doing molecular characterization research with the help of the National Nuclear Labs. And what we actually found was not this molecule that Stevenson theoretically designed, but we found another substance, even more magnificent, much larger, that we now call a carbon matrix. So this is what we found, this beautiful image I'm showing you on the screen right now. So the carbon matrix is a massive molecule. It's many thousands of Daltons in size, similar in size to the insulin molecule in our body. And it plays a vital role in exactly how soils work and provides many, many benefits. So they are highly organized molecules. They are what we call a supramolecular molecule. What does that mean? Supramolecular basically means that there's smaller pieces or smaller molecules that will self-assemble together into a much larger structure. The bigger it gets, the more powerful it is and the more function it has. So it plays a vital role in how soils behave, how water behaves in the soil, the structure of soil, how mineral nutrients are provided to a plant, and how microbes live in that soil, and what provides the environment that the microbes need to live in that soil. So where do these carbon matrix molecules come from? Well, they're not a substance that's the end result of the decay of organic matter. We know that. They are actually formed on the roots of plants, such as this image I'm showing you, where they are an anabolic process where chemical precursors and enzymes and microbes and a source of carbon, which is coming from the plant, all come together, and these molecules are then built in the soil. So this is an anabolic process, not a catabolic process. What do I mean by that? Well, if you're looking at compost, when we're making compost, we're breaking the organic matter down into smaller and smaller particle sizes until eventually you can't identify what was the original stuff that you made the compost from. And so that's a catabolic or a breaking down process. And so it's important for you to understand that this carbon matrix is not that. It is an anabolic. It is a building up process. So probably people ask me, what do you think is the most significant thing that this carbon matrix can do for us? And my answer is probably the ability to help us hold water in the soil. It has a humectant effect. So humectants is a substance that contains molecules that have functional groups on them, and get a little bit complex here, but don't worry about it. These functional groups are basically groups of atoms that have the ability to attract water and draw the water into the molecule and hold it there so that the water will not evaporate into the atmosphere so easily. Now, we put humectants into products like ice cream and lotions so that they'll stay moist. And in the world of natural science and soils, there are humectants, and the carbon matrix is exactly that. So one of the ways these humectants work is that they use electricity to their advantage. And this example here of this image of a plastic bottle with a little bit of water coming out of a faucet exemplifies what we're saying. If I were to take this plastic bottle and rub it on a stack of paper towels for about 60 seconds and then hold it up to that water stream, you'll see the water bend and go towards the plastic bottle. That's happening because when you rub that plastic bottle on the paper towels, you built up a static charge, a negative charge. And the water molecule, one side of the water molecule has a positive charge. So the positive is attracted to the negative, therefore the water is going to bend and go towards the plastic bottle. Well, these humectants in the soil do exactly the same thing. This particular image here is part of our research project that came from the national laboratories when we did this molecular characterization research. And I took just a piece of the molecule, not the whole molecule, so I can show you the actual electrical charge. Now, if you look carefully here, this molecule is going to start moving, and then you're going to see a spark coming out of it. So there's, on one end of the molecule, you'll see a spark, and on the other end of the molecule at the exact same time, you'll see a spark. Why is this happening? Because this molecule is actually capable of generating what we call an induced magnetic field. And this induced magnetic field is exactly the same thing that you did when you rubbed that plastic bottle on the paper towels, building up enough charge to be able to attract water. So if I put a whole bunch of these fragments of these molecules together that are doing this induced magnetic field, they become a very powerful humectant, capable of helping us hold more water in our soil. This is very important to agriculture or even to urban horticulture, where water is an issue, where we're trying to not use as much water, but we still need to be able to produce just as much green. So this carbon matrix molecule is our claim to fame. It's what we can hang our hat on at Soil Secrets, because we own the information, the molecular information that we were able to get during this research project with the national laboratories. The research was done under a contract called a commercial proprietary information contract. Nobody else in the world owns this information. Now, what are we able to do with this molecule? We're able to load it. We can put into this molecule nutrition that a crop needs. And so this particular slide that we're showing you is demonstrating that we can put a nutrient into a tiny nanoparticle. This nanoparticle holds a charge that can attract the nutrient, whether it be a positive or a negative nutrient. It can attract it, and then we can impregnate that nanoparticle into the carbon matrix so the farmer can benefit from it. And now remember that this carbon matrix also attracts water, so it's able to pull water in from the atmosphere, pull the nanoparticle in that has the nutrient, and wow, we have a benefit for the farmer. So, like I mentioned, we did this work with the help of the national laboratories under a contract called a commercial proprietary information contract. It's important for you to understand, though, this is not an endorsement by the national labs. This is simply just research that they did and provided us with information that we then had to interpret and make use of it. So, now, the benefit of using this carbon matrix, bottom line is improving the health of our soil. We're seeing a decline in soil health all over the planet because of the way we have managed our soils, therefore losing the carbon or the topsoil fraction of our soil. There's scientific literature now proving that because of this decline of soil, we're also seeing a decline in nutrition from the foods that are coming off of the farms. This particular study here that was published in Scientific American demonstrates that between 1975 and 1997, we had a significant drop in nutrition of our food. That's just one of many studies that have been done. So nutrient density decline in our groceries is a big problem, and it exemplifies that there's a problem with our soil. And so Soil Secrets with the carbon matrix is able to improve this situation and get the soil back on that journey to better soil health. And this means that we have to build topsoil. So when we're building topsoil, what we're doing is we're actually causing a situation to occur where we're attracting carbon out of the air and storing it into the soil. We call this soil carbon sequestration, therefore building a topsoil on our farms. And we've done this enough to be able to see a dramatic increase in the amount of carbon in our soils, and also a dramatic improvement in how much water do we have to irrigate that crop with in order to successfully grow a crop. So soil carbon, or soil molecular carbon, is very important in this equation to soil health. And as it accumulates in the soil, and we begin to see the soil improve in its behavior, improve in its ability to take in rainwater or irrigation water and hang on to that water so the crop can benefit from it, but also attract oxygen into the soil. Remember, everything that's good that has to happen in that soil, every chemical equation, everything that that plant is trying to do is dependent upon two things: oxygen and water. So if we can improve the soil's ability to take in oxygen, take in water, then we're going to be on the right journey to better soil health. Now, this slide is showing you a spot on my arboretum grounds. An arboretum is a botanical garden with an emphasis on trees. And in 1985, I began developing an arboretum in Los Lunas, New Mexico. But I did this on a site that was not the best choice of sites to purchase. The soils were a horrible saline, sodic, alkaline clay. That clay was about 12 feet deep. One of my professors from my college days told me to put a for sale sign on this property and go somewhere else, because there was no way to fix this particular type of soil. Well, after 30 years, you can see the difference in the soil in this exact same spot, 30 years apart. The image on the left shows the clay as a dispersed, collapsed clay. It's dispersed and collapsed because of the high salinity levels and the high sodium levels. And 30 years later, you can see that the clay no longer looks the same. It is no longer having the problems with shrinking and swelling. And it's become rich and black in color because it now contains a lot of carbon. In fact, it has 360,000 pounds of carbon per acre on this site, going 1 foot deep. That's a lot of carbon. And that carbon has allowed the soil to form an aggregate structure, which is now a breathable soil that is porous to water. So when it rains or we irrigate, the water can penetrate, and the swelling of the clay will no longer inhibit that water's ability to get down into that soil. So soil carbon helps to retain soil moisture. I did a little bit of math for you to show you how much it helps. Now, there are many soil scientists that believe that 1 pound of carbon can hold 10 pounds of water. Now, I can't verify that that's true, but it sounds like a pretty good number to me, so I'm going to run with it. And if it's true, then that 360,000 pounds of carbon that I was able to sequester onto my arboretum grounds over a 30-year period will now allow me to hold on to 430,000 gallons of water per acre on that site. I believe this is actually happening because our necessity of how often we have to water to maintain all these redwood trees and oak trees and giant timber bamboo. It's a huge collection of trees from all over the world that's growing on this site. That, remember, 30 years ago, my professor said, you can't fix that soil, sell it and go somewhere else. Well, today I have a collection of trees from every continent growing on this site, and the soils stay beautifully moist most of the time. So the TerraPro Ag product, which is a carbon matrix product, causes the soil particles to form these aggregates and helps the water to penetrate and be held in that soil, which also allows us to get rid of the salinity and the sodium that was previously causing a problem. So a summary of benefits here as to what this carbon matrix is going to do. It helps us aggregate the soil particles so that the soil can breathe and we can get water to penetrate. And it helps the soil to hold on to the moisture. So again, that's a humectant process. And it can help us if you have a high salinity or high sodium problem, it can help us get rid of those. And finally, it provides an environment that the microbes need to have, the bacteria and the fungi need to have, so that they can do their job. And we can, again, load the carbon matrix with nanotechnology and nutrition so that the crop can benefit from that emerging technological field. So I'm going to run through some examples of success that we've had with sodium and salinity. This is raspberries in California. The image on the left is showing damage caused by the high salinity and sodium. That field was treated with TerraPro, and you can see the image on the right that we solved the problem. This is a turf field in Albuquerque, New Mexico that was having some disease problems. There was plenty of water, plenty of fertilizer, long growing season, but as you can see on the image on the left, there's a brown spot. That's a disease problem, and so when we treated it with TerraPro, something happened that no longer favored that disease, and the image on the right shows that the turf is now doing quite well. This is a corn silage field at a dairy in California. The crop advisor who gave me this photograph told me that after using TerraPro, they discovered that they didn't need to add nearly as much fertilizer because TerraPro makes fertilizers work better, more efficiently, and so they don't have to use as much. In this case, they only use 60 pounds of nitrogen to grow this corn that is 15 feet tall. And by the way, that particular strain of corn is only supposed to get 12 feet tall, but in this case, it got up to 15 feet. Vineyards in Baja, Mexico. It's a really, really dry site. The water is precious and expensive. And when they put down 1,000 pounds of the TerraPro per mile of the vineyard, the row on the right was the row treated with the TerraPro Ag. And you can see obviously a lot more biomass production happening on that row versus the control on the left. But more significantly is the yield improvement. The grower gave us a report that showed that their yield, their tonnage, on 9 different varieties of grapes that were being grown for wine, their tonnage went up by 55.9% when they used the TerraPro. The water usage decreased dramatically. They were previously using emitters that produced 4.5 gallons of water per day, and they were able to reduce it down to emitters that produced 1.1 gallon per day. So a huge water savings. The grower provided me with these pictures of the control plants on the left, where you can easily see that the yield of grapes is not nearly as abundant as the image on the right where the TerraPro is used. So water savings, yield increase, and even the Brix levels that were the sugar levels measured on the treated grapes was significantly higher on those vines that were treated with the TerraPro Ag. So this image I like to show because it demonstrates what it should look like when you're applying this product. Image on the left is pecan trees in southern Arizona, and the black stuff, as you can see, where they did what we call a precision application, where they spread the TerraPro carbon matrix up close to the trees. They didn't put it out in the aisles where the vehicles drive, just up close to the trees. The image on the right is a pistachio orchard in California where they dribbled the carbon matrix right on top of where the drip irrigation line would lie. And so they just, for the purpose of this picture, they pulled the irrigation line to the side so you can see the black line of the carbon. When you're improving the soil's ability to accept water and accept oxygen, and also improving the plant's ability to get nutrients out of the soil, then many good things can be seen. This is a lawn in Merced, California, where the soils were getting so concreted where water would no longer penetrate, but once they treated it with TerraPro, then the soils changed and now water can penetrate, and you can see the result, a much healthier lawn. Same thing in Kansas City, Kansas, where they were experiencing a drought and a lot of heat, and so the lawns were drying out. But when we treated it with TerraPro, you can see that there was an advantage to that turf. The turf, its tolerable limits to drought improved dramatically. This is a sports field in Rio Rancho, New Mexico that I built along with a contractor on a pure caliche. Caliche is calcium carbonate. It's almost rock. And so we were able to actually successfully grow a sports field for one of their elementary schools in Rio Rancho Public Schools using TerraPro on this caliche field. It's used in urban horticulture, urban forestry. This particular site is in Albuquerque, New Mexico. In 2004, a historic neighborhood was completely rebuilt. The medians and the parkways were completely rebuilt, and the city of Albuquerque used TerraPro Ag to rebuild the soils before the planting of the trees. And we even had the opportunity to provide the trees, which came from our production nursery called Trees That Please. So that concludes my introduction to TerraPro, and thank you very much for your time. Please contact us if you have any questions. There's the contact information below, our website, our email, and our phone number. And I hope you learned something from this, and maybe someday you'll have the opportunity to be able to use TerraPro on your project. Thank you very much. We're going to do a Q&A to help you understand what TerraPro is and how it works and what the benefits are. And to help me with this, I have with me Jim Gray, who is the Business Development Officer for Sterling Pacific out of Orange, California. Jim has a long history of working with farmers all over the Southwest, and so he has a pretty good understanding of what kind of questions farmers are going to ask. So welcome, Jim. Thank you for being with us today.
It's a pleasure to be here, Michael.
And so what kind of questions would you think are going to be useful to our farmers and to our Parks and Rec people, municipalities, to help them understand what this product is and what kind of benefits they can expect to get from it?
Well, Michael, what exactly is TerraPro Ag compared to compost or soil organic matter?
Okay, that's an excellent question, Jim. All of them are going to be categorized as a soil amendment, meaning that they are going to add something to the soil to amend the characteristic of the soil. In the case of TerraPro Ag, that is a very technologically advanced material based on the science of how nature works in the soil. So we did research over an 11-year period trying to identify and successfully identifying molecules that are in the soil that are produced by chemical reactions involving plants, enzymes, bacteria, fungi, etc. And together they will build a very complex carbon-based molecular structure. These are huge molecules, and they play a very vital role in how soils behave, how they breathe, how microbes can live there, what defines the very essence of a healthy and productive topsoil. So TerraPro Ag is really the first product of its kind globally that represents this, what we call the carbon matrix. Now, it's important to understand that this carbon matrix does not come to us by way of the decomposition of organic matter. So you're not going to find them in compost. You're not going to find them in biochar or peat moss or other forms of soil amendments. These are a product of an anabolic chemical reaction in soil, where they actually are developed in the soil because all the precursor chemicals, all the right conditions exist. So we have found that by adding them or fortifying them into a soil, we can improve how that soil behaves.
Very interesting. What about yield improvements on crops, Michael? And in particular, how much product do we need to use on a particular crop? And I understand it'll vary.
It will vary because, if we're dealing with a farmer who's in the Baja Peninsula of Mexico, very hot and dry desert, those desert soils have never really developed what we would call a topsoil. And so those conditions are totally different than dealing with a nice, rich, loamy soil up in Wyoming, let's say. And so the amount of material that we would have to utilize to get that soil to behave, to optimize that farmer's productivity, profit, yield, is going to be different. There's variables that we're dealing with here. But I don't know if that answers your question adequately, but we have to look at every situation as being a unique situation.
Well, so soil type makes a difference then. How about then on water usage, and are we able to use less water because of the nature of this product?
Sure, and going back to that soil type, as most of us understand, a desert sandy soil is not going to hold as much water as a rich topsoil full of carbon that we would find like maybe in Iowa. And so a lot of the ability of the soil's potential to hold on to water is due to the electrical charge, what we call the electrical negativity factor of the soil. And so when we measure soil, doing a typical soil analysis, one of the things that we will do is ask for a cation exchange capacity value. And that's the electrical negativity value of the soil. So a sandy soil is going to have a very low number versus a heavy clay soil will have a higher number. So because of the higher number, that electrical charge can attract water and hold it in the soil. This is why sand is going to be droughty, and a nice, rich, humus-rich topsoil is not so droughty. So when we add TerraPro has a phenomenally high electronegativity factor, a very powerful electrical charge. And that's because the molecules themselves are generating this electrical charge, which I'll show you in a presentation that we're going to do here. And so if you were to put this TerraPro into a sandy soil and you use enough of it, it's going to enhance that sandy soil's ability to hang on to water. It's going to have a humectant effect. So one example of that is, again, a vineyard in Baja, Mexico, where the grower was having to add 4 gallons of water per plant per hour. I forget how many total hours they actually had to run the emitters. I think it was like 12 hours. And when they put the TerraPro product down using 1,000 pounds per mile of vineyard row, they were able to reduce the amount of water from 4 gallons per hour down to just 1 gallon per hour a significant reduction in the amount of water that they had to add. And the yield went up dramatically at the same time.
Well, that's an impressive aspect. So then with fertilizer, the addition of fertilizer to your soil, to the crop, how does it benefit the working of the fertilizer and the plant's ability for nutrient uptake?
By a huge factor, Jim. Your fertilizers are going to contain nutrients that have a negative charge and some nutrients that have a positive charge. So if there isn't something in that soil to grab that fertilizer and hold it, then you're very likely going to lose the fertilizer. And so it's been said by some of the experts in the field of agronomy and soil science that up to 90% or more of the fertilizers that a farmer buys are never used by the crop because they're lost before the crop can ever use them. So when we put TerraPro Ag into the equation, because of the huge positive and negative charges that are in these molecule complexes, it can grab a hold of those fertilizers and chelate them or hold them until the plant needs them. Now also, you got to remember that a fertilizer cannot get into a plant if water is not carrying it. And so if your soils are dry, then the fertilizers are not going to get into that plant. So if we can improve the soil's capacity to hold on to water, which TerraPro Ag will do, then we can keep the fertilizers in a nutrient solution, and now the plant can drink it.
Interesting. Michael, TerraPro Ag, you've now included into it nanotechnology. Can you explain the benefits of that nanotechnology and why you chose to do that?
Sure can. Nanotechnology really, Jim, is the future of agriculture and even the future of medicine. So when we talk about nanotechnology, what we're talking about is a carbon-based structure, a really tiny structure. Some people use the name buckyball for these structures. They're so small that we can actually manufacture them small enough to where they can pass through glass. So these structures can be charged. We can put a positive or a negative charge in them, and depending on what we're trying to hold. So if we're trying to hold, for example, a nitrogen, such as a nitrate that has a negative charge, then we can put a positive charge in that nanoparticle, which will attract the nitrate and encapsulate it, and then carry it into that plant so that the plant can benefit from it. So remember, this particle is so small, it doesn't even have to go through the roots to get into that plant. It can actually go through the bark. We could actually spray it onto the plant, and it could go right through the bark or right through the cell walls of a leaf without going through the openings and feed that plant. So what we're doing with TerraPro Ag is that we're loading the carbon matrix. Remember, this carbon matrix has powerful charges itself, positive and negative. Remember when you were a kid playing with magnets, and the stronger the magnet, the harder it was to pull it off of another magnet. You know, so if you turn the positive of one magnet towards the negative of another, they'd stick together.
Yeah.
If they were weak, it was easy to pull them apart, but if they were strong, you had to put some muscle into it to get them apart. Well, TerraPro Ag is a strong, and it can grab a hold of stuff like water and minerals and the nanoparticle and hold it. So we can actually combine into the TerraPro every mineral nutrient that a plant needs, and charge it into that nanoparticle and put that nanoparticle inside the carbon molecule. And that way we can make sure the entire environment is exactly what that plant needs.
So with the addition of nanotechnology into TerraPro Ag, you've incorporated biologics into it. So how does the TerraPro Ag benefit the microbes?
Well, microbes have to breathe, and they need oxygen. The beneficial microbes that live in the rhizosphere of a plant, that's the zone immediately around the roots of a plant, those are aerobic microbes, so they have to get oxygen. So the carbon matrix is actually capable of delivering oxygen to those microbes. So it's participating in microbial respiration. So any microbe that's already in the soil that's a beneficial microbe is going to get helped by the TerraPro Ag carbon matrix. But we can also add microbes to this product that we know are going to improve the nutrient uptake of that plant. For example, if you have metals in the soil like iron that are combined with phosphorus, so that's not a good situation, by the way, when they're combined, because they won't oxidize, and if they won't oxidize, the plant can't use them. So we can put microbes into the TerraPro that will oxidize the iron phosphate and therefore make them available. We can also put bacteria that are capable of fixing nitrogen. We call them free-living nitrogen-fixing bacteria. When they're free-living, they don't even need a plant. They can do it on their own. Now, we're all familiar with nitrogen-fixing bacteria that associate with your legumes, your nitrogen-fixing plants like alfalfa and clover. But what if you don't have a legume as a crop? What if you're growing cotton and or you're growing corn, and those are not capable of associating with the nitrogen-fixing bacteria on their roots? Well, if we put this free-living nitrogen-fixing bacteria into the carbon matrix, that free-living can now live in the soil, and it can fix nitrogen at a fairly significant level, so that we have a very steady and constant supply of nitrogen to that crop.
So it can help to create a better active community going on down there. We talked about soil types, and in particular, clay soils are very difficult to work with. So what have you seen the advantages of using TerraPro Ag in a soil that's affected by clay?
Well, one of our problems with clay has many benefits, but it also has some downsides.
Yeah.
One of the downsides of clay is that when it gets wet, it swells. And when it swells, it seals. And once that sealing process takes place, it's very difficult for water or oxygen to be able to penetrate down into the soil. And remember, everything that's good that has to happen in that soil is contingent upon water and oxygen. And so if the clay has sealed, your soils are going to go anaerobic. That's not a good thing. The aerobic bacteria don't like it when the soils go anaerobic. So what happens when we put ag-grade TerraPro on clay, and it's all, I mean, we're getting into some very complex quantum physics here as to how and why this works, but the clay particles will actually be attracted into aggregate structures, and this, once you have this aggregate structure to the soil, the porosity of the soil has been improved, and now oxygen and water can penetrate down into the soil, and everybody's happy.
Very interesting. One of the other unique things I find out about TerraPro Ag is you talk about a one-time application, the lifetime of that soil. How does that work?
Well, when we did the molecular research to first of all find the carbon matrix, and then second of all describe it, because it's never been described before. By the way, the reason why we did this study is because we were trying to be the very first people on the planet to describe humic acid, because that's never been described. And so the result of the study was we found something else. We found something better, and it's called the carbon matrix. And so the carbon matrix, when we did this study, we were able to do an aging analysis to see how fast does it decay or go away. And so you can determine the chemical half-life when you do this kind of research. And we basically found out that this substance is going to last thousands of years in the soil, a lot longer than what we have to be concerned about. So when we tell a farmer that every pound or every ton that you put into the soil is going to stay there and continue to work, that's pretty exciting. And so if we discovered that a particular situation, like for example, we were able to bioremediate some mine tailings that were toxic. Nothing would grow there. These tailings were over 100 years old, and after 100 years, still nothing would grow there. And when we put down 2,000 pounds per acre of this TerraPro Ag on that site, it chemically changed the site so quickly and so dramatically that within a couple of weeks, we could grow grass on that site. Now that 2,000 pounds will be there 3,000 years from now. That's a one-time fix.
Michael, again, in conjunction with how it works, it comes down to the cost per acre for most farmers. What can you say about that?
Well, there's variables on every site that we have to consider. So if we're dealing with a heavy clay soil with a lot of salt and sodium, and we know we're going to have to use at least 1,000 pounds of this product per acre, then the cost is going to be roughly at about 50 cents a pound to use this product. If we don't have that situation, but we're trying to improve the water holding potential of the soil, and just generally put the farmer on the journey to better soil health. And so we don't need to use 1,000 pounds. We might want to use just 500 pounds. Then the cost would be about half of that.
Another question, Michael. We want to look at tools that maybe can be used to measure the benefits of TerraPro Ag. What would be some of those tools that you would recommend?
That's an important question, Jim, because a lot of times we have a bad habit of just looking at the ground or looking at the crop and asking ourselves, can I see a difference? And that's not a reliable way of knowing that you're making a difference. So it's sort of like, with our own personal health, if your doctor told you that you have high blood pressure and high cholesterol and you need to lose about 20 pounds, and you decide to go out and start jogging in the morning, and you're going to eat a high roughage cereal for breakfast and more vegetables for lunch and dinner, after the first couple of weeks of eating like that, can I look at you and see a difference? Probably not. And so we have to have tools in our toolbox to be able to measure progress. One of the tools that we have seen used by crop consultants is a device like this. This is the same thing that if you walk into an office building, you might have somebody point one of these at your forehead to see what your temperature is before they let you into that building. But this is a thermometer. And so we have seen certified crop advisors point this at the foliage of orchard trees like pistachio trees and almond trees, and they can see during the heat of the day that those trees treated with TerraPro are going to be cooler. The foliage is cooler. And that's a great sign, because if the foliage is cooler, they're able to conduct photosynthesis longer into the heat of the day. The stomata will stay open and that plant can continue manufacturing energy from the sun if the foliage is cool. But if the foliage is hot, that plant is going to get the message, it better shut down those stomata, stop losing water, and therefore stop photosynthesis. So the longer we can keep photosynthesis happening into the day, the more yield we're going to get of whatever it is that crop is trying to grow, whether it's pecan nuts, pistachio nuts, corn, whatever. The length of photosynthesis is very, very important. So this is one tool. Another tool that I've seen used is a rod with a gauge on it. It's called a penetrometer. And this can actually be pushed into the soil and measure how hard is that soil. Now, civil engineers use this same tool when they're going to build something, and they have to get the ground to a certain compaction before they're ready to put a slab on it. And so, but in agriculture, we don't want the ground to be hard. We want it to be the opposite. So you can use a penetrometer to measure a change that's taking place in terms of what's the PSI, the pounds per square inch in that soil. In the case of TerraPro Ag, we've seen orchards in California go from a 300 PSI before treatment, and within the first growing season, that PSI has dropped below 75. That's going the full length of that rod, a 3-foot long rod. That's a huge drop. Now, I've heard soil scientists say that the microbes of the soil cannot live very well in the soil if the PSI is above 150. I don't know how true that is, but it sounds like a good number. And so if it's true, then when that orchard was at 300, that's a bad situation. So if we put down 1,000 pounds of TerraPro Ag per mile of trees, and the way it's put down is basically just dribbled down right on top of the drip irrigation line. So a band about 3-4 inches wide, 1,000 pounds of it per mile. And before the first season is over with, you can walk anywhere in that field. You can be 15 feet away from where that TerraPro is put down, and you can push that penetrometer in 3 feet deep and be below 75. That's progress. Mm-hmm. So another tool that is going to become really the standard of agriculture is drones. And these drones can be outfitted with a camera so that they can do what we call a vegetation analysis using infrared. So we can ask the camera to tell us, is there an improvement in the chlorophyll in that crop? And it'll see it. Where the naked eye won't see it, the drone will. Or you could ask the drone to tell us what's the temperature. And you can see the hot spots in the field that you need to pay more attention to. Or moisture. You know, is the soil moisture staying adequate in the soil or in the vegetation itself? So drones are they're the future of how we're going to be doing this.
Well, one last thing, Michael, and we talk about the physical measurements of the soil. Isn't it important for the farmer to know the health of his soil going in? So we need to take those soil samples, like our blood workup, to determine what the starting point is for what we're doing, and then come back later to see what the benefits of the TerraPro Ag might be.
Absolutely. You know, one of our success stories is a sweet potato grower in California who was able to see an improvement in the yield from 18 crates. A crate's roughly 1,000 pounds of potatoes, but from 18 crates up to 45 crates per acre. Now, this grower did something different. He actually had the potatoes analyzed to see what were the vitamin and mineral levels in those potatoes. Did it improve? And there was a significant improvement in the level of vitamins and minerals. That's important to know because we're seeing a calamity right now happening in our groceries, in that the value of vitamins and minerals in our groceries is plummeting. There's studies that have documented how much they have dropped in just the past 30 years. It's a big drop. So we're going to have a problem with malnutrition just because the food coming off of our farm soils is not nutrient dense. And so the farmer has other tools that they can use beyond measuring the actual nutrient density of the food. They can also measure the crop. During the growing season, they can do a sap analysis to see what's going on in the fluids inside that plant. They can do a tissue analysis to see what's going on in the actual tissues. And we can even do bacterial, microbial, fungal analysis of the soil. One of the more recent methods of analysis that's come out is called a phospholipid analysis. And so we can actually do a before and an after to be able to track our progress and are we on that journey to better soil health.
Well, I appreciate the time, Michael. Thanks for answering the questions. I believe this is all beneficial to all of us.
Well, thank you, Jim. I appreciate you being here today to help us answer some of these questions.
Thank you, sir.
You're welcome.